But cyclic hydrocarbons are so called because they make cycles, they make loops, they make rings. So far we've dealt with hydrocarbons that make straight chains. These have included saturated hydrocarbons, alkanes, those with double and triple bonds, alkenes and alkynes, and those that contain any number of functional groups, right? Our alcohols and our aldehydes and our ketones and our carboxylic acids. Hydrocarbons are able, however, to form bonds between the first and the last carbon in the primary chain. No reason they couldn't. How many how many bonds can carbon make? 4, right? And so is there any reason that the last carbon in a chain and the first carbon in a chain couldn't bond to each other? Of course they could, right? So if we, for example, were to take pentane, we all know its structure, 1, 2, 3, 4, 5 carbons with hydrogens like this. That is pentane. What's its formula? C5H12 is correct. Good. On the other hand, what if we made it into a cyclical molecule? In other words, what if this carbon and that carbon were stuck together? We would get a pentagon in shape. 1, 2, 3, 4, 5, like that. Now, every one of these would be able to make bonds to hydrogen thusly. And we call this cyclopentane. And if we wanted to draw it as a stick diagram, we would just draw it like that. Right? Because there's no need to draw hydrogens. Whereas we draw this as 1, 2, 3, 4, 5. I'm going to draw those below. 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. Now, what's the formula of cyclopentane? Cyclopentane, this one over here. C5. Is it 12? Yeah, because keep in mind that we've lost 2 bonds, right? The first and the last carbon are no longer free to bond to that third hydrogen because they're bonding to each other. So they have different formulae. The general form of an alkane, if you remember, is CXH2X plus 2, right? Does that ring a bell? So like pentane was C5H12. Double it and add 2. C6H14 would be hexane. But a cycloalkane, what's the general form of that? Yeah, CXH2X. I'll give you a minute to get that copied down. Now, the one thing I want to note is that this isn't... we haven't shown a synthesis up here. We just said verses. Does that make sense? The actual process by which this could happen is actually pretty complicated. You don't need to know this, but just to show you down below, forming cycloalkanes is complex. That's a great question. What's the hybridization state of everything in pentane? sp3, so all the bond angles are? All the bond angles are? That's okay. 9.5. What's the hybridization state in cyclopentane? sp3, so all the bond angles ought to be? Yeah, and if you look, you'll see the result of that is the ring doesn't sit flat. The ring has to kind of bounce up and down, if that makes sense. So if we go, I actually happen to have been working with glucose, which is a complex cyclic structure because it's got an oxygen in there. We'll just do a simple one, but see how it bounces up and then bounces down again at 109.5 degrees. If we just do cyclopentane, you can see from above it might look like it's sitting flat, but in fact, that 109.5 means that it goes down and then back up and then down and then back up. Can we see that? So the angle is 109.5. Great question. So this is not a nice, simple structure. See the angles sort of, they almost look random, but they're not random. It's just that 109.5 isn't a nice, easy number to work with, right? So you don't get a flat surface kind of from any three things or whatever. Well, sorry, any three things do form a plane. In math, have you ever talked about the wobbly table theorem as a proof for continuous functions? No? Don't worry about it. Anyway. But this is true. Do you know that for any four-legged table, you can prove mathematically that no matter how wobbly it is, no matter how uneven the legs are, on any surface, if you spin it by 90 degrees, somewhere in that 90-degree spin, it will sit firmly on the ground. It has to. It's a mathematical proof of that wobbly table theorem. So if your table is wobbling and you don't have time to adjust the legs or anything like that, if you just keep rotating it somewhere within the first 90 degrees of turn, it will find a nice stable place. Now, that doesn't mean it'll be flat. You might end up with a table like angled like this, which wouldn't be helpful for you, but it will sit flat. Wobbly table theorem, that's what they call it. Yeah. Okay. The first four cyclical alkanes are shown below. Why isn't there a cyclomethane or a cycloethane?
Because you don't have enough carbons to make.
Yeah, right? Like that. And its shape. In theory, I guess you could, like whatever. Ethene is sort of them making a double bond with each other. It's still not making a ring. It's just a double bond, right? So the smallest one would be cyclopropane, followed by cyclobutane, followed by, what are these? Cyclo. It does look like a D, doesn't it? But it's cyclo. This is cyclopentane, good. And this is cyclo... 1, 2, 3, 4, 5, 6. So cyclo. Very good. So you already said that?
Yeah.
Oh, sorry. I didn't hear you. How's that feel? Not too bad? Now, you might be asking, the only question with this might be, what do we consider carbon 1? And the answer is, as long as there's nothing in it, it doesn't really matter what you consider carbon 1, right? It has radial symmetry. It is rotationally symmetrical. So you can call any carbon number 1 that you want. Does that make sense? In a cyclic molecule, any carbon could be considered number 1. In a regular molecule, you only have two choices, either the one on this end or the one on that end, but it has to be a terminal carbon, right? You still have two choices. You can number from the left or number from the right, but you only have those two choices. In a cyclical molecule, you can call any carbon you want number 1. Yeah. Ah, you're so good. Yep. If you have a functional group, what are you going to call the carbon it comes off of? You're going to call that number 1. Exactly right. Totally up to you. Totally up to you. By convention, I think more often we go clockwise, but you don't have to. So, with that in mind, I want you to try and draw this one. Can you please draw for me 2-bromo, 1-chloro, 3-methyl cyclopentane? 2-bromo, 1-chloro, 3-methyl cyclopentane.
You're so fascinated with that.
Always.
Mr. Orlando.
Speaking.
Just a work period today, third period, right?
Is that what I said?
Yeah.
Then yes.
Can I go to the presentation in the library?
Oh yeah, you bet. What is it?
It's college presentation.
Oh great. Yeah, no, of course. Of course. Oh my goodness.
I already handed in the genetics assignment.
Oh, did you?
Yeah.
Beautiful. Look at you.
I don't know how well I did it, but
I bet you did great.
Mr. Orlando,
Yeah.
for the genetics assignment, how should I, because I have it all on the Google Doc, should I put that into the assignment and then hand it in and then you can print it for me?
Yeah, that'll work.
Okay.
I shared it to you and made you editor, and then I put the link in Teams.
Oh,
it
you're so
should
good.
work.
You're amazing.
It should work.
It'll work. That's amazing. Get Odette, you're my hero. It is annoying that like the DSPN's default security things are so like intense that it's like even when you share a link by default, people don't have access unless you've specifically named them, which is really annoying.
Or set it.
Or set it.
Anyone with the link.
For a while they had that blocked. You couldn't set it anyone with a link, which was really annoying. I think it's back now because I think we screamed and yelled and made
Well, I think it's anyone with the link within the DSPN. I think is the
which is fair. That's a
Yeah.
fair compromise.
Mm-hmm.
All right. What's this going to look like? Somebody want to talk me through this? Sure. Yeah, go ahead. Okay. Did you draw carbons or did you just do the skeleton?
Skeleton.
Okay, so like, is that right?
Yeah.
Okay.
And then I chose the very the peak as it for my first carbon, so I put that as the CL.
Okay.
well, this is an
And
actual.
I did clockwise, so I did bromine as like the
There.
yeah.
Beautiful.
And then after that I put just a line for
Beautiful. That's great.
This was a reach ahead for us.
Yeah. Yeah. No, I've been looking over sort of where people. You guys don't know this, but I put the work in. So I reach out and I look at, and I always ask people who've gone on to university, what did you feel well prepared for? What did you struggle? What did other people know that you didn't know? And then I adjust my class. I want to make sure that you guys are as well prepared as anybody. That's important to me. So this was something that people thought that would have been good if they'd, had at this point. So we make sure it's in. I pay attention. Believe it or not, I do pay attention, team. Good. That looks great. Well done. Name this abomination. Well, there, right? This is a side chain. So that's okay. I think you can do this. I want you to try this. Just remember, if this were by itself, what would we call it? Cyclopropane, right? So as a group, what will it be called? It's a cyclopropyl group. Yeah, it's cyclopropyl group. In this case, on carbon.
1.
No. 3. Good. Hi, how you doing? Can I help you?
Can I interrupt you?
Sure, of course.
I have a question for you.
Oh, for me?
The volleyball stuff
Yeah.
that I have to try and solve.
Yeah.
Have you seen them?
Yeah, it's really good.
Okay. So like,
Are you doing this thing? Are you doing the leadership assignment?
oh yeah. This is my schedule for day 1. This is like before I switched up the team. So right?
Yeah, all I've done so far is the round.
Yeah, it's gonna be a good minute to do. So I think this is like the main chain, right? And so number 3 is that's like that's like it's not going to second and then it's starting to meet metal. So it's like a propyl, it's methyl. What is we're now
Is it?
This is a point. So that doesn't show that.
I'm not.
Isn't there a method?
It's right here. Or 10.
I don't.
So it'll be like 6.
No, it's just telling. No, it's nothing because it's telling you because you see how there's one on here. I think it's just telling you what the carbon and. Because you see how it has it at the first one too. I think it's just telling you that this is a carbon and it has 3 hydrogens, just because it's both skeleton and carbon diagram. Just so you know that that's carbon. Why is dimethyl? Because they're doing it both at once. No, because this is still so the carbon. You see how it's labeled as 10. I think they just did that with adding the actual carbon in both one.
Oh, that's not
So it's just telling you that it cuts off.
Oh, but it's not actually.
I don't believe so because see they did that for number 1. That means there's a methyl at 1.
Okay.
But that would just add on to it.
For double,
Because you can't have
do you
a
make the
carbon
schedule the same when
at
you make it for
the end without it adding, so it just adds to the chain.
The schedule is, remember the draw? Where we did.
Yeah, like T1, T2,
What is that?
T2, T5.
For double elimination, it's the brackets.
I didn't.
The schedule is the
I
brackets.
slept all day.
Because then you know what I'm saying?
Yeah, I remember. Okay.
But Miss Pitchell took her assignment to mark it of the example for that, so you'd have to go out of your brain. You have one.
But she gives
resembles
up.
nothing of another.
She gives us another red, and then at the same time she gives us like 5 of them.
Okay.
So at that point she's just.
It's many.
So at that point she's actually. And then you. You're not. You just give up cussing. That one weird cussing. I'm like always cussing over every summer and it's really most random shit.
Oh, I'm not because
Is that right? Does that look right?
You're the one telling us that.
This
Oh, why did you get
so there's second carbon, so that's the main one. Then there's 2 E, so on 2. On 1 all, so 1 alcohol, then methyl. So yeah, I'm only done.
My only question is, where did you find them?
Because I even tried it and I realized I wrote through that, so I'm like, I'm gonna draw it, you know, again. It's extra fancy. Extra low. Hey, pointy.
Or something on mute, everybody see him?
Oh, look at the another book.
All right, team. So, what do we call this? It's got a name for me. Yeah.
I got 3 cyclopropyl 6 methyl decane.
C3-cyclopropyl. 6.
Yeah, 6 methyl decane.
Yeah, that looks great. Great. And of course, we could throw that into mole view, and it should find it just fine. What was it? 3-cyclopropyl, 6-methyl decane. There it is. Exactly what we had drawn, right? We all see that?
Is that exactly what we draw?
Pretty much. If we want this back as a skeleton diagram, there it is. And what a skeleton diagram. Yeah.
Carbon. You have to mention CH3 or no? Because in the diagram, I thought it was a metal.
No, this particular diagram, this is the thing you'll see sometimes, that they show you terminal carbons by noting them CH3. It's a thing you can do, but you don't have to do. Weird thing about skeleton diagrams is anytime you want to draw a carbon, if you think it's useful, you can do so. And anytime you want to put hydrogens on, you can do so, but you don't have to. You saw that in your assignment, right? Every once in a while there'd be an annoying little hydrogen there, which is just like, there's an annoying little hydrogen there. It's never wrong to show a hydrogen. It's never wrong to throw a carbon. But I usually, if I'm working with skeleton diagrams, then I kind of try to work with skeleton diagrams. But yeah. Did that answer your question? It was a good question. And B, don't forget to change A into ill when naming the cyclical side chain. Yeah. Cyclical hydrocarbons may also contain functional groups and double bonds. Numbering priority is alcohols are more important than double bonds, are more important than halides and alkyl groups. So if there's an alcohol on the loop, you're going to make sure that's carbon number 1. If there's not, but there's a double bond, you're going to make sure the double bond's number 1. If there's no alcohols and no double bonds, then halides and alkyl groups, the ones that go out in front, you would do just like we normally do. Does that make sense? So please draw for me 3-bromo, 2-methyl, cyclopent, 2-ene, 1-ol. Yeah, do you want to draw it? I'll come to you.
Does that look right?
Sure, looks great.
Hold on, wait, let me try and get it. Okay.
You're doing great. Don't let them give you a hard time.
That's a shape.
Yeah. Oh, sure.
It's an A shape.
Sure.
No.
I'm shitting for drawing the
As I always say, you don't have to be in shape. You can just have a shape.
Whoa. What are these?
I don't know that you want to commit to that.
Right, I know.
I really don't like the part where I like switched up the teams because like all the issues talking about it.
What do we think? How's that look?
Terrible.
Team 1 will still be on.
I know, it looks great.
Yay.
All in favor of Sarah's the teacher now?
So I switched them to
All opposed?
I switched
All right, Sarah, keep going.
Oh, okay, yeah. Wait, let's see what's else. Okay.
Keep going.
Uh-huh. Uh-huh.
All right, read it.
No, I'm reading in my head, so like
Read it
y'all
aloud.
can like read my
No,
mind.
that's not how teaching works. Read it aloud.
I did not. Can I like not all in favor, Sarah? Because like
You lost. I'm sorry.
Sarah just read the sentence.
benzene is a 6-carbon ring with alternating single and double bonds.
You're gonna get, can I give you some teaching advice? When you don't know what you're doing, just throw it out to the class. Be like, all right, what's that look like?
What does that look like, guys? Thoughts, opinions? Yes, Sam.
It's a hexagon.
Wow. Anyone else? Angela, I saw your hand up. Continue. No, I heard your hand. Yep.
I was saying it looks like we're working. Sarah, that's what I have. It's Chow.
I'm not that. I can't
You
see.
can see it. It's okay. Just look a little bit harder.
There's a reason why I have glasses.
Just look a little bit harder. It looks like a hexagon with alternating double lines.
A plus to Sam.
Okay.
Uh-huh. Oh, am I supposed to like draw it? I got you guys. I would. Oh.
What the
Oh, hold. What was that, Sam? Stop it!
It's a hexagon. Yeah, how it's a hexagon.
Go for it. My bad.
You draw.
No, this is my like. That. Oh. Did you guys like that? Okay.
Yeah, well,
Is Chow, why are you drawing it like that?
Because I want to. Yeah, that's it.
looks like a real nice thing.
And if we're, Miss Chow, would that have hydrogens as well?
No. Because, like, it's. Hold on.
Oh, why'd you draw?
Oh, no, yo.
Are you not supposed to draw the skeletal structure?
Does it matter, though?
What?
I'm not getting paid for this, guys.
May I say, that's great. Normally, we would draw them to the outside. For reasons, why would this not be the favored way for that to end up going? Look at the angles. What do we know the bond angle is?
120.
120. So that only works if those lines are going out, got it, right? Yeah, beautiful. Very nice.
I have a question, Mr. Ron.
Yeah.
If you're drawing like a normal alkane, could you draw the methyl inward or?
A normal alkane, the still not going to be inward, but they will kind of sit above and below, right? Which is a matter of like just, you can look at the geometry, right? Like they're not going to end up on the inside because that would end up with a really small angle, right? Like as it is, the angle between these is 109.5. So now this would be like half of that, but you're not going to see that, right? So they're going to sit outside at 109.5 degrees. Did that answer your question? It was a good question. Okay, so keep in mind that we have two possible structures here, right? We have this structure, or we have this structure. That looks terrible. Oh my goodness. Great job, by the way, Sarah. I meant to say that. These are both valid structures. What do we call it when there are two valid structures where those pi bonds shift? Those are resonance structures. So the other way we could indicate that is we could say that these look kind of like this, right? These are resonance structures. Which means that you can think of these as being 1.5 bonds each. You could find the formal charge of every carbon involved here, right? Yeah.
Could you alternate, like, when I drew it, I went outside, inside, so that, like, I could differentiate?
If that helps you. Sure. Yeah, that's fine. Yeah, totally fine. The question is, if it helps you kind of visualize it, could you sort of show it like this? And yes, absolutely. If that's kind of more clear to you, nothing wrong with that. Oh, I'm good today, but thank you so much. Benzene is a really important compound. It shows up in chemistry over and 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 over again. You're going to see benzene all the time. All right? So this structure is known as benzene. We call compounds made of benzene aromatics. Yeah.
So, like, when I say benzene, is it always like a 6 carbon?
It's always 6 carbons, always with that double bond. And it has its own special symbol that you'll see sometimes. Which, yeah, gets its own, that was 5. It gets its own special symbol that you probably have actually seen without knowing what it is. This is an accepted symbol for benzene. Kind of. It's just, it comes up so much it gets its own symbol. Is that fair? It's because it has a resonance structure, but this is just something we see so much. Now, what's the hybridization state of benzene? So what do you know about benzene that's kind of cool? Geometrically. Sorry? Exactly right. Very good. It sits perfectly flat. So if we go to mole view, oh, that's not mole view. If we look up benzene, it sits perfectly flat. That kind of fun? Whoa. Okay. Whoa, man. Okay, so draw these for me. Methylbenzene, chlorobenzene, benzenoic acid. Benzenoic acid is going to get a triple star because could you put a carboxylic acid on this? Not possible. Because a carboxylic acid has to be on a terminal carbon. So what we call benzenoic acid has to have an extra carbon coming off of it. Does that make sense? It has to have a branch with an extra carbon, and that's where the acid is. All right? So try making all of these. Methylbenzene, chlorobenzene, benzenoic acid. And again, our little note here that because each carbon in benzene can only make one bond, benzenoic acid requires a carbon to be bound to the benzene ring to which the double bond O and the bond to OH are bound. So draw those. Yep. Doesn't matter which one, because whichever one you pick, that's going to be carbon 1. Yeah. Oh, today's? Right here, my friend.
Thank you.
You're welcome. So, our first one is methylbenzene, and that's benzene with a methyl group, right? And we draw it like that. So, methylbenzene. Okay, what about chlorobenzene? Same thing, but with a Cl instead, right? Oh, shoot. And benzenoic acid, like we said, this would actually probably be better named like something else, but it's got the carbon up here, and that has the carboxylic acid group in it. So benzenoic acid needs an extra carbon. It's kind of poorly named, actually. Now, sometimes things will have a benzene group as a side chain. And we don't call it a benzyl group. I don't know why we don't call it a benzyl group, but we don't. I mean, that's kind of a goofy name. But frankly, so is benzene. And if you have an uncle benzene, I apologize for that. But kind of like a silly name, you know? You'd call him Ben for short, I guess. So when it's a side chain, we call it a phenyl group. Why would it have to be a side chain if there's a functional group on the main chain? Does that make sense? If there's a functional group on the main chain, we don't want to name side chains with functional groups. So instead, we'd prefer to call the other one the main chain and just call this the side chain. Does that make sense? It gets to be a real pain when you have to name a side group that also has a functional group. So phenylethene. Ethene would just be carbon double bond to carbon, and then to our phenyl group. 1, 2, 3, 4, 5, 6. Alternating double bonds. There it is. How's that feel? Not too bad? What about phenylethanoate? What kind of compound is that?
That's an ester.
This is an ester. See if you can draw that. When you've done that, you've got the remainder of this period to work on whatever it is you may need to work on. But of course, hopefully that includes getting your assignment 2.3 into me so I can get those graded. I got a few 2.2s to return here, by the way, which K-Dot will return for you. I want to mention something. With any of the randomized assignments, if you want to take another crack at it, feel free to come talk to me because I can just make you a new one that's randomized, right? So if you're unhappy with your grade, now listen, having said that, if you come to me with like your 98 and you're like, I really feel like I could do better, I'm going to yell at you and tell you to go away. So let's just save each other the indignity. Is everyone clear on that?
What's the cutoff?
I don't know. The cutoff is use your common sense. I would say certainly the cutoff is if it's the same or higher than your current grade in the course, then the grade seems reasonable. You know what I mean? Is that fair? But just use your judgment. Like honestly, to be like, hey Orlando, can you do a bunch of work so I can turn my 98 into 100, which will have no statistical impact whatsoever on my grade? Seems inconsiderate to me, right? Okay, so just be considerate. There you go, kiddo.
Mr. Orlando,
Yeah.
can I go on my phone very quickly to turn on my hotspot because this computer will not connect to the school Wi-Fi.
Yeah, you bet. Go ahead.
So I can only connect it to my hotspot.
Yeah, totally cool. It's also because, like, the other side of that philosophically to me is I kind of don't believe that there's such thing as being perfect if you need a second try. I have no problem with second tries. I think that's important in life. But do you know what I mean? But I kind of don't think you should be able to say, yeah, I got perfect on that thing if it took 2 tries. I just do think that there's a next level. When you're talking about being at that absolute upper echelon of being a student, well, at that point, getting it right the first time matters. Though in general, I support second tries of things.
You only handed me like 5.
I think I'd already given some back, and then some I haven't marked yet. In fact, if you want to grab the hand-in folder for me. This class is hand-in, yeah, I'll grade whatever's there. All right, phenylethanate. If we have an ester, generally speaking, an ester is a bunch of carbons, then we get an oxygen, and then we get a bunch of carbons on the other side, and one of the sides also has a double bond to oxygen, right? Which one of these is going to have the double bond to oxygen? The phenyl side or the ethanoate side? Is that true? Yeah, the one that has the O8 is the one that has the double bond to oxygen. Makes sense, right? Oh. Hey. I don't know. I don't know what to tell you. So anyway, we have a phenyl group. That's easy. I said it's easy and then immediately screwed up drawing it. Oh God, I'm going to screw it up again. Okay, there we go. Like I said, easy. And then it goes to an oxygen. And then it's going to go to an ethyl group, right? But it's an ethanoate. So what do I need here? Double bond to oxygen. Phenyl group, ethanoate. Is that cool? I'm cool. All right. So we know that. You guys can work on what you're working on. I'm here to help you if you need me. Failing that, get your assignment 2.3 into me. If you don't, you're late. I'll take late marks off. And also I'll throw things at you. What's up? Yeah, it's not a big one, but it's not something we can do in 15. Why don't we just get it on Monday? Is that cool?
On Monday, I have school Monday.
Let me get it on Tuesday.
Oh, great.
Because honestly, it was just a demonstration. It's not like a big thing. It just,
What day is Walton doing it?
That's what I was about to ask.
Why don't we do Tuesday?
Tuesday?
Okay.
Is that cool?
At
Because again,
lunch or
sure,
after
yeah,
school?
lunch. Or after
Can't do
school.
Tuesday at lunch.
Can't do Tuesday at lunch.
Council.
Council.
And Tuesday after school. So.
Yeah, so it is. And we could do it today at lunch. Do you want to do it today at lunch?
Can't do today at lunch.
Okay. Well,
Today after school?
today after school works for me.
I can do today after
Okay,
school.
why don't we do it today after school?
How
Cool.
long will it take for?
Like 30 minutes.
Okay.
Thank you, Mr.
Cool. So if anyone else missed yesterday's lab, because again, yesterday's lab, there's no assignment associated with it, but it's something you need to know. It's going to be fair game to ask you about. So, yeah.
Actually, we'll be missing Monday's lab.
Monday's
We'll be at
lab?
basketball.
Oh, you guys are killing me. Well, we'll have to catch that one up. Yeah, we'll have to catch that one up as we catch it up.
Okay.
That one is that one's got a report. So,
You're doing it on Monday? What's the specific?
we're making esters.
Oh, with the smaller one?
Yeah. Hi. Look at it.
Can I take the assignments again?
Yeah, you bet. 2.2? Yeah, I will make one up for you. Get that by the end of the day, okay? I would print it for you right now, but my printer is missing a toner waste container, which they want to maybe pay $72 for. I'm not paying $72 for a bucket for waste toner. So I'm trying to find a cheaper place to buy one.
Well, they've actually made 3 so it's restricted. You can need access to District School Board of Niagara, so anyone in the school board, and then anyone with the board.
Oh, you can use that now. That's cool.
I'm still gonna add you this thing.
I'll check my email regularly, so if you email me saying it doesn't work, I can change it.
No, listen, you've done your due diligence. I'm not going to give you a hard time. That was, if at this point it doesn't work, that's not your fault. That's just security gone awry. So you are fine. Don't